this is my second example of finding the inverse of a quadratic function. So let's start with this function. So let's say f of x is equal to negative 3 x plus 2 squared minus 5, right? And where x is less than or equal to negative 2. Okay? So let's start with question 1. As always, find the domain and range of f of x. Okay? So step number 1 is obviously we've got to sketch this. So this is really simple to sketch. I am going to draw that over there. And so I know the vertex is negative 2 and negative 5. Negative 5. And since it's negative 3, it's facing down. So it's facing down this way. So it's facing down this way. And now let's apply the domain restriction. So x is less than negative 2. So this will definitely be a closed circle. And since it's less, I'm going to erase everything to the right. And there you have it. So now let's determine the domain and range. So the domain is x is element of reals. And first, obviously, the domain is given to us. X is less than or equal to negative 2. And the range is y is element of reals. And we simply say y is less than or equal to negative 5. All right, so hopefully that works. And now B says find f inverse. So like I did before, what I'm going to sort of do on the side, this is just a side note, right? I'm going to find the domain and range of the inverse. This will become important for me later. So since I have the domain and range of the functions, I can determine the domain and ranges of the inverse. So since x is element of reals, this is going to be x is less than or equal to negative 5. And the range is y is element of reals. And it's going to be y is less than or equal to negative 2. All right, so that's just on the side. It's going to be helpful in a second when I get to finding my inverse. So, so when we do that, so the first thing that I'm going to do is we'll just write the function out. Y is equal to negative 3 x plus 2 squared minus 5. So step number 1 for in the inverse is switch x and y. So x equals negative 3 y plus 2 squared minus 5. First, we're going to add 5. So it's going to be x plus 5, because I want to get rid of that. It's going to be negative 3 y plus 2 squared. Next, I'm going to divide by negative 3. So when I do that, it's going to be negative 1/3 x plus 5 is equal to y plus 2 squared. And then what I'm going to do is I'm going to square root both sides. So remember, I'm going to write plus or minus square root this time. But remember, it's just temporary. It's just temporary. So 1/3 x plus 5, and that's equal to y plus 2. And my final step is y is equal to negative 1/3 x plus 5. So the square root of plus or minus, and then it's going to be minus 2 because I subtracted 2 from both sides. Or sorry, did I do this? Yeah, it's going to be minus 2 on that side. Okay, so now let's determine whether it's going to be plus or minus. Remember, because we have to determine whether it's correct. Because if we put both of them, it's no longer a function. So only one of them is valid. So first, let's sketch this out. And what we can see right away is that the point is negative 5 and negative 2. So that's this point right here. And this negative tells us that there's a reflection across the y-axis, right? So if I have this positive, which means basically the y's it's not reflected across the x-axis, so it would go like this. And then if I do this negative and that negative, it will end up like this. So the question is, which one of these two are valid? So in order to determine that, we need to look at the domain and range of the inverse. So this is why initially, when I made that side note, I said the domain has to be x is less than -5, and the range has to be y is less than -2. So the range is actually going to be the bigger clue here. So y is less than -2. So as we can see, for both these inverse functions, both of them are x is less than -5. So we don't have to worry about the domain. But if we go back over here, the range of the inverse function, the range of the inverse function has to be y is less than -2. So in other words, this one applies because y is less than -2, but that one doesn't. So what I'm going to do is I'm going to erase that top function, right? And since it's a reflection across the x-axis because it's facing down, I'm going to keep the negative and I'm going to remove the positive. So my final answer then is that f inverse of this function, is equal to negative the square root of -1/3 x plus 5 minus 2. And that is my answer. And yeah, that's my answer. So just to go over this one more time, basically, how did I decide upon that? First, whenever you're finding the inverse, it's always a good idea to write its domain and range based on the original function. Then, when you actually get around to determining the function, make sure you switch everything. And when you get to the square root part, leave it as plus or minus. Leave it as plus or minus. And sketch both functions. Sketch the plus one and sketch the minus one. Then depending on the domain and range of the inverse function, which you determined on the side previously, erase the one that does not make sense. So in this case, we erased the top one because y was less than 2, not greater than 2. So since y was less than -2, we erased the top one, and since that's a reflection over the x-axis, that's minus, so we kept that negative, and this is our final answer. So this is our final answer for that, and I hope that makes sense, and I guess I'll see you in the next set of videos. Take care. Bye.